Ultrasonic grinding machine. CNC machine tool. High-performance lathe bed. With so much advanced equipment. This workshop is undoubtedly a leader in the industry. Light up some kindling. Toss it into the furnace. Open the valve to ignite the furnace. And a thick plume of smoke rises. It's like something out of a mystical scene. The guy adds enough fuel to the furnace. Usually diesel. Diesel is common, cheap. And most importantly, it has excellent combustion properties. It's stable, relatively safe, and perfect for small-scale foundry furnaces. The pistons are made of aluminum alloy. Tossed directly into the furnace. The workshop isn't big, and the furnace is relatively small. They can't produce much in a day, but they ensure everything is freshly made. Recycled materials produce aluminum with more impurities, so they usually add some refining agents. Commonly sodium chloride, potassium chloride, and fluorides, which react with impurities in the aluminum at high temperatures to form slag. Once the aluminum is melted, it's time to assemble the mold. The piston mold is relatively simple, consisting of a base and 5 insertable sliders. If something's not aligned, a couple of hammer taps will fix it. Everything fits snugly together. Then, flip the work table. Since the pouring gate is on this side, place 2 specially designed baffles. Scoop a large ladle of fresh aluminum from the furnace and pour it straight into the gate. The mold is well designed, with semicircular vents on the side. The biggest fear during pouring is the formation of air pockets inside. The aluminum solidifies quickly, and after 2 minutes, the mold can be opened. Use a hammer to break open the pouring gate and chisel off any excess material. Flip the base. Pry open the pinholes and remove the sliders. Once the centerpiece is removed, the rest can be gently tapped loose. The freshly solidified aluminum is still very hot, so it's cooled in water. Then, it's taken to the bandsaw to cut off the excess. Admittedly, the excess material is a bit wasteful, but it's necessary to ensure air escapes during pouring. That's why such large air vents are left at the bottom. This is an electric oven, used for tempering the pistons. Tempering reduces internal stresses in the aluminum alloy, improving its stability and fatigue resistance. In engines, aluminum pistons operate under high temperatures and pressures. Tempering reduces the risk of deformation and cracking. This machine is a rare sight in Pakistan. An ultrasonic grinding machine. These are small steel beads for grinding. Fill it with water and start the machine. The high-frequency vibrations create a unique splashing effect. Once the grinding material and agent are fully mixed, the pistons are added for a thorough 2-hour massage. Afterward, they are taken out, washed to remove any foam. And carefully inspected for any air pocket defects. This step requires meticulous attention. No defective pieces can move to the next stage. See this? This is a CNC machine, a whole generation ahead. of manual machines. It's a true product of Industry 2.0. Just press a button, and it automatically completes the task. Next, drill a few oil holes in the piston walls. Don't underestimate these small holes. They allow lubricating oil to flow, reducing friction between the piston and cylinder walls. The lathe work is smooth as butter. One cut, and the pinholes are flawless. Next, carve a groove inside the pinholes, and repeat on both sides. Then, move to the CNC machine to process the piston head and cylindrical surface. This third-generation lathe, a smart CNC machine, integrates AI, big data, and IoT technologies. It's highly intelligent. For example, operators can monitor the machine remotely, via phone or computer, identifying and solving issues in real time. The grooves being machined now, after the compression and all rings. After machining, check the dimensions, fit the pins, and the piston is complete. Hey, folks, give a thumbs up to Pakistan's Industry 2.0. See you next time.